What is up, car and tech fans, and welcome to another garage tinkering video. If you've been following the project making new gauges for my 350Z, you'll know that the things we focused on so far is A, extracting as much information as we can from the CANBus to display on the new gauges, and B, the design and user experience of creating those gauges in LVGL. But what happens when we get to a piece of data that we want to display that isn't available in the CANBus? How do we take it from the car and display it? That's something we're going to look at a bit today, because the piece of information that I really want to be on my gauges is the oil pressure. And the oil pressure is not available on the CANBus because of a weird little way the 350Z goes about handling. Let's just take a look at what it does and why it's not there. Down at the bottom of the center console, underneath the gator surround, is this little box, and it's called the unified meter. And what we have in here is a bunch of the sensors from around the car, which get fed into this box and then redistributed to parts of the car. And part of that involves sending the battery voltage and the oil pressure as analog wave signals up to this little clip which goes into the back of the triple meter. What that means is it displays the oil pressure, which is the one we're going to look at, as a voltage, and it sends a varying voltage between two limits, which the triple meter then converts based on some ratio or formula into a PSI value. So what we need to do is use ADC, or analog to digital conversion, done within an ESP32, sense what that voltage is that's being sent to the triple gauges, which we're doing away with those triple gauges. So then we need to convert that voltage and figure out what the formula is to convert that voltage number to a PSI number, so we can use the existing clip straight into an ESP32 through a custom PCB that we'll design. And then in the same way that we've done from the CANBus and from the GPS and our other sensors and things, we can distribute that value with ESPNow to the rest of our devices, and they can use it when they need it. The process of actually sensing that input and then converting it isn't all that difficult. What's going to be a bit more tricky is figuring out what voltage relates to what PSI. In order to figure that out, we're going to have to do some manual testing. So let me show you what we're dealing with and how we're going to do it. This is the triple gauge meter that I've already removed from the car, and you see we've got the oil pressure in the middle, battery voltage, and then this multifunction display. Then there's a clip on this side. It's got 12 pins in it and this little clip, and when we put that in, these receive different things. So one of them is the oil pressure, one's the battery voltage, and there's a bunch of other stuff in there. So how we're going to do this is we're going to start by removing this. And it's the fact that we can access these on the back, which are just right angles to take the pins and put them into the PCB. I have the documentation for this from the service manual, so let's just take a quick peek at that. So this document here is the driver's information for the 350Z. Now, there are loads and loads of these PDFs, and they break down everything that happens around various parts of the car. This one happens to be regarding driver information. So it's the main driver's cluster that we can see here. Here's the triple meter. So everything here tells us all the ways that it's connected, everything that it does, or ratios or maximum ranges. It tells us basically everything that we would want to know about how that thing works. And as part of it, when we get down to here, this is the wiring. We've got just a connection of how everything all is made together. But the important thing, the thing that we really care about is this clip here, M44, because M44 is that clip that is behind the top of the center console that we want to plug into. We can see it's got 12 pins. When we go down just a little bit, this is that triple meter reference, and these are what those 12 pins do. From the first one is the ground, so top right is ground. We're going to need to want to know that that is there. And we've got a battery power supply, which is always on. So if we wanted a constant power supply, that'd be a great place to get it. And then an ignition switched power supply. So the third one in is only if the ignition is on, that one's going to get power. So if we only want the screens to turn on when we've got the ignition on, maybe there's a little hint of something that's coming there. And we've got these two connections to the unified meter, which sit below. And then a couple of others, these ones power and get ground for the oil pressure. And it sends the oil pressure sensor signal. So when the ignition is on and basically but the engine isn't running, that should give us approximately 1 volt. And then when the engine's running and the oil pressure is 500 kPa, which is, when you convert it, about 72 psi, it should be roughly 3 volts. And then it'll run up and down through different values. So what we're interested in here is ground. Obviously, we need to ground our circuit. The ignition switched on or off, because once we switch the power on, we could then use that to power our gauges and this little extra sensor we're going to do to find the oil pressure, plus the oil pressure sensor signal. So this will range between 2 values, and we need to find out what those values are and do some comparisons. And in order to do that, we're going to have to do something a little bit clever, and it's this. We're going to have to take this out to the car, plug it in, and we want pin 8, which is the one underneath here. It's second one in. So if I bend this to the side, bend that to the side, so I've got space but still nothing's touching, I can get my multimeter through here, touch that pin, second one in, so number 8, and the ground, which is this top one here, and test what the voltage is in between those 2 pins. And then whilst I'm doing that, refer to the oil pressure here and see what voltage we're getting at each oil pressure. Now, it's going to start high when I turn the car on, somewhere between 90 and 120, and then slowly reduce as the engine warms up. So I'm going to try and capture it at 90, 60, and 30 psi, because if I can get it at those 3 and see what the voltage is at those 3 values, then we can use that to create a formula which will roughly tell us what the conversion rate from voltages to psi is. And honestly, that's going to be the most tricky part of this process, because it's all a little bit fiddly, and they're going to have to, twist it, quickly take a reading, say it out loud, blah blah blah. So anyway, let's just do it. Let's go out into the car, take some readings. It's going to look a bit chaotic how I do this, but hopefully by the end of it, we get the numbers that we need. .30 psi is 1.5. Okay, so it's 1.5 at 30. Let's move it up to 60. Yeah, 2.5, and then 90. .5. Okay. As mad as that process seemed, we've got the 3 values that we want. So let's use AI to figure out the formula. We could do it in a manual way, but why bother when AI can do it for us? I believe in using technology when it's a good idea to use it, and I think for this it is. So what do we need to tell it? We need to tell it that 30 psi, my voltage is 1.5 volts. At 60 psi, it's 2.5 volts. At 90 psi, it's 3.5 volts. What is the formula to convert from volt V to PSI given a max range of 1 to 5 volts. So that should give us a formula that converts from one to the other, and hopefully they all work together. And you'll probably know if it's right if the formula is relatively simple, because you wouldn't expect it to be a super complicated formula. And it's working it all out. 30V minus 15. That seems relatively simple. So PSI is 30V minus 15. So if we test that, it said in that documentation that we looked at initially that approximately 500 kPa should be about 3. So what would 3 volts give us in kPa instead of PSI? And it should just convert volts to PSI. So it's going to be 3 times 30, 90 minus 15, 75. So it's 75 PSI, which I just said it's about 72. So we're in the right ballpark. Right. Final answer. 3V is 517. And as the documentation said, 3 volts should be 500. So it's within a reasonable enough margin of error. Great. So we have figured out our conversion formula. So we now know what voltage comes in and what that relates to. One additional problem here we have, though, is that our ESP32 chip cannot sense 5 volts. If you give it 5 volts through an ADC, an analog digital conversion pin, one of the GPIO pins, it'll overload it. So we need to convert the voltage from a maximum of 5 down to a maximum of 3.2, because in the way that ADC pins work, they kind of, if you look at the data sheets for ESP32s, they read a nice kind of pretty linear conversion from 1 through to 3.2, and then 3.2 to 3.3, it like flattens out. It doesn't recognize the difference at the top end. So if we convert it down to 3.2, then that gives us a nice range, and we can do that pretty simply by using a voltage divider. So what a voltage divider will do is just basically use 2 resistors very, very simply, and it'll take the 5 volts in and it'll split the signal and it'll allow 3.2 volts to continue on, which is exactly what we want to do, and just knock the system down. Because we're only really sensing a signal, it's not powering anything, we don't need a lot of current flowing through the system. So we only need like 1 milliamp. That will be perfectly fine for what we want to do with this sensing. We know we've got 5 volts coming in, and the mathematical formula that we'll use to get from voltage to the final current is voltage divided by resistance is equal to final current. So if we've got 5 volts coming in, we need about 5,000 ohms of resistance in order to get to 1 milliamp. So the 2 resistors that we pick for our voltage divider should, when combined together, be around 5,000 ohms. So if we use a website like ohmslawcalculator.com and use this voltage divider calculator, we can put in a couple of values and then find out what resistors we might want to use. So we've got our 5 volts coming in. We know we want 3.2 coming out, and we'll do these in kiloohms because it's going to have to add up to 5,000. And typically speaking, what we're trying to do is find out a percentage. So 3.2, we know that's about 3/5. It's in that ballpark. So the resistors here, one of them will be about 2/5, and one of them will be about 3/5 of 5. So one will be just under 2. So if we were to put in 1.8 kiloohms for our first resistor, our second one would be 3.2 kiloohms, which are nice, simple, easy numbers. So we'd create this circuit we'd have 1.8 kilo ohms as this top resistor, 3.2 kilo ohms as this bottom resistor, and then the output here would be 3.2 volts. So they're good numbers. Now, you can use different ones. You can obviously, you could update this to 5 kilo ohms if you want, and then you'd have to have 8.889 or, 1 kilo ohm here, maybe 1.7. As you lower and increase these numbers, you lower and increase the amount of current going through. And we want the combination of these two to be pretty much 5,000. And I'll admit, I'd figured this out already. So I knew that 1.8 thousand plus 3.2 thousand is exactly 5,000. Maths. We know we need an ESP32 with an ADC input that we can sense that voltage from. And we know we have a 14.5-ish, like a dirty car battery signal that we can use to power the thing. So we need to make a PCB. I've actually already done it. So let's just take a look at it and I'll explain what I've done. So this is KiCad. If you've never used it before, it is for creating custom PCBs. Apparently, the way that I use this is horrible. And whenever I put things onto certain Reddit groups for feedback, they tear into me about my schematic design and it doesn't conform to standards. They're for me, for the most part. It doesn't matter if it doesn't conform to a standard. But anyway, this is the input. So this is our 12 pin, and these are going to be the 12 pins. I'm going to stick off the board, and we're going to make a socket that can go down to them. The top right one is the ground, and we've got the 14.5 volt input onto that third pin in, because the third pin is the switched voltage. And then the oil pressure, the raw signal, comes in on the second pin in. So these are just the inputs. Then I'll explain why we've got these additional switches up here in a moment. The oil pressure then comes into a resistor, which is 1.8 kilo ohm resistance, goes off to oil low, and then at the other side of it is the 3.3, that's 3.2 kilo ohms that comes out the opposite side, which means that this oil low is dropped down to 3.2. Then on our Arduino here, we're going to be running it from a 5 volt rather than the 3.3 for a reason I'll bring up in a moment. And then we're using this pin down here to sense our oil low. Now the eagle-eyed will notice that I've got PPS and GPS stuff here. And it's because I already have an Arduino that is intending to live behind that part of the center console, and it's the one I'm using for weather and GPS and all that. So it doesn't make sense to have one ESP32 that just does oil pressure. I might as well hook the oil pressure into the GPS one that I'm already using and already distributing ESPNow data from, and just add one extra input to it. So as well as having the oil pressure stuff come in, I've got the GPS connections that run off the GPS module that I am using, a GTU7. All the information will be in the description if you want to see the individual components, but we'll see it a bit more in a minute. So then we've got a mounting point here, which is for that GPS. It's got 5 mounting pins. So the PPS, which is the pulses per second, we use for accurate timings, the GPS, TX and RX, the 2 serials, the ground, and then the 5 volt in. And this is why we're running it at 5 volts. The GPS module requires 5 volts. So that's what I'm going to be running it off. Unfortunately, the Arduino can run off 5 volts completely happily. But also, there's 3 other outputs here, 3 sockets, which have got a 5 volt and a ground. It's because we've got 3 gauges. And we already need to knock down that 14.5 volt signal from the car to this Arduino. We need to knock it down to 5 volts. So at the same time as knocking it down to 5 volts for this Arduino, we're going to distribute that same 5 volt signal 3 other times for the 3 other screens. So this one module is going to power all of the gauges plus this GPS module, because there's plenty of current that comes through. We only need about 2 and a bit amps to power all of this stuff. So when we knock it down to 3-ish amps, we've got plenty of headroom. It's all fine. I've tested it. It works. And then up here we have the 14 volt-ish in and a 5 volt out. And this is a off-the-shelf step-down module that I'm going to use just purely for safety, simplicity. I've got a bunch of voltage step-down modules that are safe up to 40 volts, and I can choose the output voltage. I've got a variable output, so we can use them anywhere between, well, I think they go down as low as 1.5 or something like that, all the way up to 12.5 volts out. So I can just adjust that to give me 5 volts, and it'll make life a lot easier. The way to see this a bit more clearly is actually on the PCB design. So when we move over to that, see this, including my stupid face, there it is, the Nissan 350Z gauge splitter with GPS. So we're going to have our ESP32 here with the antenna, and then over here is where we're going to have our input, our clip that comes from the back of the gauge cluster, the original clip. So this will clip straight into the car. It will ground on that pin. The VCC, so the car's switched power, goes down this track and into a input here, which is the input on these little knockdown modules. And it's got the input and the ground on one side, and then 5 volt out on the other side. Then that 5 volt out will distribute to the Arduino on the board, and 3 outputs, which we can then connect with wires. I'm going to put some little mounting points on here. Then we can connect those out to the gauges. And then there's also another power that distributes up here, which is where the GPS module is going to go. The various outputs from a GPS module that go into the Arduino. And then here, we're just going to have to solder on those resistors. So the 1.8 kilo ohms here and the 3.2 kilo ohms here. And then that just goes along there to the oil low input. One thing we have to be careful with the ESP32 is the fact that it has 2 ADCs. It's got ADC1 and ADC2. And if you're using Wi-Fi or Bluetooth or any of those kind of like wireless connections with an ESP32, which we are going to be using for ESPNow, ADC2 will not work. Wi-Fi takes over ADC2. So you want to make sure you're going into an ADC1 connection. I think this one's going into pin, I think I picked pin 32. Can't remember off the top of my head. But this is what it looks like. And if we look at it in 3D, there it is. So this is what our board is going to look like. And we can see with the mounting points kind of how it's all going to fit together. So GPS module here, step down voltage here, Arduino here, and then we plug in the car at this point. Yes, I could have spent ages figuring out all the individual components for the step down and then the GPS. And, you know, we could have integrated it all into one board. But this, really, we're in our prototyping stage and we just want to make sure that everything works. So we're going to be using simple boards with off-the-shelf modules for now. And then we'll create a second iteration down the line, which has all the components built into it. Fortunately, the production of these boards has been taken care of for me by the sponsor of this video, PCBWay. If you've been in and around Tinker projects and electronic projects like this for a while, I'm sure you know who PCBWay are. Industry standard at creating really high quality, low cost boards. And I've genuinely used them for years anyway. So it's fantastic to partner with a company I actually believe in on this and other ongoing projects. If you follow the link in my description, you can get $5 off your first purchase. And if you're getting some boards like this, they only cost $5 anyway. So you're effectively getting them for free. I actually got these boards ordered 5 days ago. Took 24 hours for them to finish making them. And then 3 days later, they're in my hands. So let's take a look at what we got. So these are the boards and they're great, but I need to solder all the components onto them. Anyone who's followed this channel for a while will know I hate soldering. I'm not very good at it. So rather than sitting and watching me struggle for an hour, here's a quick montage set to an AI-generated song about how much I hate soldering. Enjoy. My hands shake like leaves on the longest nights.
Can't keep the iron steady, can't get it right. I've built castles with my mind, but this wire's my plight. Burning bridges instead of soldering tight. Got dreams of steel, but my skills ain't real. Fumble with the flux, it's such an ordeal. Oh, I've painted skies, yet this pain I feel. Can't make connections with this cursed steel. Singing Soldering Blues, baby, it's a heartache tune. I'm good at many things, but this ain't my boon. I pick up the iron and I feel the gloom. Solder blues, baby, in this dimly lit room.
So with everything seemingly working, we can wire in the screens and everything. Just make sure everything's working and the power is distributing correctly for at least 2/3 of the screens, because I have just dropped one of the screens and then I stood on it and the ribbon is broken. I'm -1 screen. So I've had to order another, and it's not going to be here for like a week. Yay! Well done, Andy. But anyway, let's plug 2 of the other screens in and see what we get. So as we can see, everything is powered on. These have got some information that's being sent through from the GPS. So the GPS over here is working, even though that light's not flashing, which means it's now not connected because I brought it away from the window, so that makes sense. It sent information out to these devices, and they're getting power correctly from the terminals over here. At the moment, the pressure that we will be hooking up to the pin in here is coming through to pin 32 over there. At the moment, that information is being ignored, so the code hasn't been written in here to create this oil pressure graph. So the ADC signal in here isn't being converted to a number to allow it to be used on this pressure gauge. So what we need to do is set up this pin for the ADC for oil pressure, convert it using the right formula to do ADC conversions back to a voltage, then onto a PSI, and then broadcast that with the rest of the information that's going out onto this screen. So we already know our voltage to oil pressure conversion rate when going from 0 to 5 volts down to the oil pressure. But when you're using ADC on an ESP32, when you're reading the value, you don't receive like 3.2 or 3.5 as a voltage value. You get a number from 0 to the max of that pin. So 0 volts is 0, and it actually tops out, like I said, that graph tops out with a little flat bit at the top. It tops out at 3.2 volts at 4,095. So we need to do a little bit of maths to go, okay, that 0 to 4,095 is representative of 0 to 3.2. So what does 2,000 on the graph mean in PSI? So there's a number to convert from the ADC value to the voltage, and then there's another one to convert from the voltage to the PSI. But if we're clever, we can just miss out the middle one and go straight from the ADC value to the PSI. And that's what we've got to figure out. So let's do a little bit of a write down of how we're going to convert this number and figure out the formula. As we know, our current calculation to go from the voltage that is used in the car. So the car's voltage is 0 to 5. And to go from that to PSI, we do 30 times car voltage, so just car B, 30 times V minus 15. So if we've got the value of 3 volts, it becomes 90 minus 15, which is equal to 75. So 3 volts is 75 PSI. And this is how the car calculates it. But we're not going from 0 to 5. We're going from 0 to 3.235. The thing is because we're not reading this as a number, it doesn't matter. Doesn't matter if we're reading from 0 to 5 or we're reading 0 to 3.235, because the ADC pin in an ESP32 reads from 0 to 4095. And that's just an integer value, so just an int, that is basically saying what proportion are we reading. And an ESP32 always reads from 0 through to 3.2 volts. And this is close enough that I'm not going to let it worry me really. So that 0 to 4095 relates to this, but it also relates to this, to 0 to 5, because it's just a proportion of the range. So if we were reading this car value and it was able to read up to 5 volts, and we were reading this value of, say, 2000, which is, let's just say, for all intents and purposes, is the middle. It would be 2000 divided by the maximum, 4095, and that would give us, it would be a roughly 0.5, and 0.5 of 5 is 2.5. So a reading by the ADC of roughly half is roughly half. And it would do exactly the same down here. It's 2000 divided by 4095 is, for all intents and purposes, 0.5, which if you multiplied by the real range that's coming in, 3.235, would give you approximately 1.6 volts. So it's about half. But if we convert it with a max of 5, it will show us the car's value. So we just do this, instead of being times 3.235, we just do times 5, and we don't use that. So our final formula to go from what is read on pin 32, what number is being read by the ADC in this 0 to 4095 format, is the ADC, which is just the value that we'll get on the pin up, divided by 4095, times by 5, which will put us into this scale, which the car originally uses, and all of that times by 30, and then minus 15. So this just replaces voltage with the ADC read divided by 4095 times by 5. And that will give us it in the correct scale. But let's just simplify that formula a little bit so it's a bit more readable and we can do it in fewer steps. So it's 30 times ADC over 4095 times by 5 minus 15. So we'll do 30 times 5 is 150 ADC over 4095 minus 15. Then we can distribute the 150 into the brackets. So we end up with 150 ADC over 4095 minus 15. Then the 4095 divided by 150 leaves us with ADC over 27.3 minus 15. And that is a much simpler way of doing it. So that's our final formula. So we're writing this code in our GPS sender module. So this is the GPS sender module so far. We're not going to really worry about anything that's going on in here, other than the fact we're going to need a new structure that is very, very simple. It's just going to have a flag so that the gauge that is receiving that information can differentiate it from the other GPS information. So I've got this common file, which I'm currently using, which if you want this code, it'll all be available in the repo, which you can take a look through. I'm not going to worry too much about any of this, but I want to add a new flag type. So just define flag, and then this one is just oil pressure. Usually they're a bit more broad, but this one is actually just doing one thing. And because I've got that in a common file, I can automatically just reuse it in the gauge. So we come into our ESP GPS sender. We'll need a new structure for it. So type def structure oil pressure, and it's going to have a flag in the same format as all the other ones do, and then just the oil pressure value, and we're going to do all the truncation and the rounding and all that stuff on this board so that the gauge doesn't have to worry about it. The gauge can just receive the value and update the UI. So it's just an unsigned int, because if we've got negative pressure, something is gone really horribly. Oh, int. Why are these not unsigned ints? They should be unsigned. Make sure. Oh, got a few. Unsigned int for the pressure. So oil pressure, and then we'll create a data element for it. Structure oil is oil data. Yeah, that's fine. So oil data is what we're going to need to use, and then I'm going to go into the setup at the bottom. Going to add a new task. So I'm currently requesting the weather every amount of time. I'm sending the date time every amount of time. That's probably going to change. I'm restoring the location. I want a new one that's a high priority, so 3, because it's like pretty important, and it's going to be send oil pressure, and this one's going to have happen a lot. So send oil pressure. So that's the name of my new function. We have a similar function here, send date time. So we just update that to send oil pressure, and then I need to decide what I want the period of time, how often I want the oil pressure to be sent, and I want it to be sent a lot. So every 200 milliseconds. But we should do this in proper variables just so we can keep track of everything. So send oil pressure interval, and at the top I have all of those intervals. Where you at? Intervals. Here you go. So send oil pressure interval. That one is sent every 200 milliseconds. So update oil pressure every 200 milliseconds. So the last thing I need to do is I need to read the ADC value from the pin, do the conversion using the formula we just done, put it into the object, and then send that object onto the gauge. And we're only sending it to the levels. Yeah, we're sending it to the levels meter, because we're not sending it to the other ones. I'm going to send it oil data. I send it all the oil data. We need to set the pin that we're going to be using for the oil pressure. So just at the top, we just define pins, because I haven't had to do that with this really yet. So just define pin for the oil is 32. And then we could do an analog read of that pin. And we want that to be just an unsigned note. Yeah, unsigned, that, which is because it's going to be a VIG value. It's just used a regular old int. So ADC read is going to be that number. Then when we've read that number, we need to put ADC read into our formula that creates the PSI. So PSI is equal to, where's our formula? So the ADC read, divide it by 27.3, and then it already does a int, so it'll remove any of like the float after values. So it's what we want anyway. We could round, but I think for a PSI it's not going to matter. The minutia of it, we'll just round down. It's fine. So the last thing we need to do is the oil data, the object that we set in the top, dot oil pressure is equal to PSI. And then we send that new PSI level, and we do this every 200 milliseconds. In theory, this should all work. Let's stick a serial print in here because we're going to need it in a minute, because we're going to have to force some voltages into this pin and then see what it says. So let's print just PSI. That's fine. And upload that to the board. I think it's as simple as that. So it has worked. I use worked loosely. It's spamming -15, which makes sense because at the moment it's reading nothing in the pin, which means the final value is 0 and then it's -15 from that. So it's doing -15. So we need to put just a quick minimum in here. So the minimum PSI is 0. So if PSI is less than 0, PSI equals 0. Easy peasy. So that just gives us a bottom level. Simple. This is now updated. That pin is now correct. I just need to quickly update the gauge so that the gauge A has the signed versus unsigned int issue fixed and has the new way of just receiving the oil pressure object, which it doesn't currently have. So in the levels gauge, we need to duplicate that structure. So the oil pressure structure here. Where are my structures there? And then we're now not going to, oh, hold up. Yeah, so oil pressure it currently thinks is coming from the CANBus, and it's not anymore. So we can change that. And then these all need to be changed to unsigned ints. Otherwise, it'll freak itself out. And then we can do the structure in here again. So the structure oil data is equal to the structure that's coming from the oil pressure. We created this global flag here, flag oil pressure, which means when we are reading our ESPNow, we do a switch based on what happens. So we can do a new switch based for if the flag is oil pressure. And if it is, then we take the incoming data is oil data. And then we can just do oil ready is equal to true. Need to add the flag to our volatile list. So oil ready. And then at the very, very bottom, we've got these. So we can do another one of these if time ready. This just makes sure that we're only doing the updates of the things that have actually changed that we need to update. So this one would be update oil, whatever I've called it, update oil pressure. And then oil ready. Let's reset to false. And then just find that. I think that will take, need to take the values out of not levels data anymore. So oil data. So it just gets the new oil pressure. Oh, and just where I have the ESPNow. If the flag comes through as the data being sent is the oil pressure, then it will just get the oil pressure data and set it into this oil pressure data object and set the oil ready to true. Then this little loop at the bottom is going ding, 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 really quickly. So the update oil pressure, well, let's upload it to the screen. Okay, well, it's currently reading 0 PSI on the screen, which is good. So now if I attach another adjustable step down into the circuit and attach it to the pin that is going to be receiving the 0 to 5, and I adjust it, we should be able to play with the output PSI and see it move between the ranges. So let's do that. And if that works, theoretically speaking, this is ready to go back in the car. So I'm going to keep the screen just attached to the computer out of the way. But yeah, it's reading 0 PSI currently. And I've got another one of these identical step down modules. And I'm just going to voltage in on there. Voltage ground on there. We'll connect it into this same distributor. No. Live on that side. So if I give that power, should all light up. And then I just want to measure this output voltage here and move it into a range that's actually safe for this. So this is going to, this pin, remember we've got the step downs here, so this pin is going to want to receive a maximum of 5 volts. So we're just going to see what it's at and just make sure that it's not a value. I've not got it set to like 35 volts and anything that could potentially really damage. So 2.4, so I'm just going to turn it up ever so slightly. So what we need to do is turn everything off. Off! This switch is norked. And the female to male, I'm going to just ground the circuit. So go out this out and into one of these, because these are all my grounds that are going to my external boards. And then the other side, the positive out, I'm going out of here and into the pin that is the sensing pin. It'd be a lot easier if I hadn't already put this catch on. You know what, I'm going to make my life a lot easier here. Remove all this and just take this off. So before I turn the screen on, let's just see what the voltage rating, make sure I'm ground. The voltage rating of this little thing is right now 2.75. So we'd expect it to be in the region of, you know, the middle. So like 60 PSI, give or take, maybe a bit over. Let's have a look. 61. So it's kind of like in the right ballpark. We expected 61 at, well, 60 at 2.5 PSI. And it's a little bit higher than that, 2.7. And the idea is here to show that everything is working. If we take this little adjuster, which adjusts the voltage output of this, and if I turn it right and left, we should see this move up and down like pretty instantly with it. So let's go up to start with. There we go. All the way up. I've got a feeling my maths is slightly off. So originally 90 PSI here, when we read it in the car, was 3.5 volts. So if I read that, it's 3.7. So that's a little bit high. And if I take it down to 30 PSI, that was 1.5. 1.72. So again, everything's a little on the high side. Now, there are reasons for this. Potentially, the ADC converter isn't perfectly linear. It has a habit of like being slightly, I think, slightly over. So I might need to do a little bit more compensation, or there are some libraries that smooth out that ADC line a little bit better. But the big important thing here is that pin, which will be connected to the sensor that comes from the car, which reads from 0 to 5 volts, which we're simulating here. When we change it, it changes the PSI value really nice and quickly and looks great. Actually, let me switch this into an alternative mode and see how it looks when we put it onto the track mode as well. And so here in track mode, it does very much the same thing. So just simulated car noises. So that's our PSI, and it's all working nicely from here, which means I can finally do the last part of this, which is creating the enclosure for it, updating the clip so that this thing can clip basically straight into the car, and this can run straight off the car. I need to make sure there are outputs on this side where there's holes so I can run cables that power the 3 gauges. But fundamentally speaking, this all does exactly what it's supposed to do. It takes and converts that oil pressure. The GPS is not currently doing anything because I'm sat inside and the blinds and everything are all closed. So I'm not surprised it's not getting a GPS signal right now, but this is all working wonderfully. Yes, this video probably had a lot more parts in it than you would usually need to do in order to get this process running. If you're going to do something like this, all you really need is to make sure you've got your ESP32, it had the ADC pin, it's receiving that voltage, it's stepped into the range, and then you read that number, you convert it to your correct output, whatever that formula might be. And then if you're doing it in the same way as me, you broadcast that number via ESPNow to your gauges, which then need to pick it up in the right format and use it on their screen. Actually, there are a lot of steps. This video was entirely worth it. But, you know, obviously we've done extra bits in there, like creating the custom PCB that holds everything and making sure that it's able to connect into the car in an OEM fashion, just to simplify everything as it moves forward. But yeah, we can take any old sensor. It could be oxygen sensors, they could be temperature sensors, they could be pressure sensors. We can read that voltage value and then distribute it in a way that we can then display on our fancy new digital gauges, which is really cool. The next step for this is going to be a little bit of like behind the scenes work, because I now need to adjust that formula a little bit so that when it's at 2.5 volts, it's actually at 60 psi. It's not at 55 or whatever it was. So there's a slight little bit there. Like I say, there are some libraries that exist that smooth out that ADC conversion line a little bit better. So maybe that'll be the way to go. But by the time one of the final parts of this video comes along, that will all be done and you'll get to finally see it in the car or doing everything. I wanted to get these in the car in the next few days, but having just broken that screen means that's not going to happen. So it's going to take at least a week for these replacements to arrive. Good thing I've got all the 3D modeling and stuff to do in the meantime. So we'll get to the final part of this next week, maybe, if you're lucky, if I'm lucky, if we're all lucky. I want to drive my car. I hope that's helped if you've ever thought, okay, how can I take analog sensors and put them onto fancy digital gauges? Because that's basically how you do it. If you have any questions about the whole process, stick them in the comments below and I'll try to answer them if I know the answer. Or you can pop along to our Discord. We've got a couple of hundred makers in there now all sharing their projects, and it's really good to see a lively creator space around these kind of like cool gauges and car hacking and all that stuff. Anyway, whatever you do with the rest of your day, folks, have a wicked one, and I'll see you next Wednesday, 2 p.m. Take it easy, peeps. Bye-bye.